Hey there, here's Jan from Jovo, and today I want to show you a complete example how you can build and deploy an Alexa skill and a Google action that works with two stages. One stage being a dev stage for local development, and the other stage being a prod stage that can be deployed to AWS Lambda. And we're going to use Jovo version 4 for this, which was released last November. After quite some time working on it, it's a complete overhaul, comes with lots of improvements. I hope you check it out. And I'm going to use a new example that we just released last week for this. And so if you go to our website and go to examples here, you can find the Alexa and Google Assistant on AWS Lambda example. And I'm going to help you set everything up step by step. And the first step being just cloning this repository. And so go to the terminal and use git clone. And then go into that directory. And we can already open that in our Visual Studio Code in my case. And also what we need to do is install the NPM dependencies of that project. Okay. So while it's installing the NPM dependencies, let's take a look at the project structure. I won't go into too much detail regarding the components here, because this is a typical sample Hello World Jovo project, which includes a love-hate pizza component that just asks the user if they like pizza, and if they respond with a yes, they say, yes, I love pizza too. This is just showing errors while the NPM dependencies aren't installed yet. So what this example includes is what I mentioned earlier, two stages. So we have one dev stage for local development, and you can see the configuration here in the app.dev file, which uses FileDB. It's a local file-based database, and the Jovo debugger, which is helpful for local development in the browser. I can show you in a minute. And then we have the prod stage for AWS Lambda, and that is using DynamoDB as a database integration. We're also going to talk about this in a few minutes. And here's the default configuration. So the stage configurations get merged into the default configurations, basically. And here we use Google Assistant and Alexa as platform integrations. And we also have our two components from here registered here. So that's on the app side. And so the dev stage uses an Express server, which is used as a local development server. The prod stage uses Lambda here, and you can even test it without having to create a new Alexa skill project, for example, in the Alexa developer console. You can just run the local development server in dev stage and get started using the Jovo debugger. And we can do this by using the Jovo run command. If you have not installed the Jovo CLI yet, you can do so with npm install globally @jovotech/CLI. And then you can use the Jovo run command. And this is going to build the files, compile the TypeScript files, and then we can open the Jovo debugger by using the .key here. And so this is the webhook URL. We're going to talk about this in a minute as well. Okay, so this is the Jovo debugger. So this is hosted on Jovo servers and is connected to your local development server. And so if you click the launch button here, for example, it goes right into your local machine. So you can see that here, that it logs the request and the response in the terminal. And the debugger is just a bit easier to try out different things. And so, do I like pizza? Yes. And then it says, yes, I love pizza too. And you can even take a look at the life cycle here and take a look at the full, like all the Jovo properties, user data that is created and stuff like this, and then the response. And so if you run into problems and want to dig deeper, I recommend using the debugger and take a look at the lifecycle view. Okay, so that's the first step. This is usually how people get started when building stuff with Jovo, just with a local development, the dev stage, and the debugger. However, of course, since there's lots of platform-specific features, usually we recommend also, even for development, for local development, we recommend creating an Alexa skill in the Alexa developer console, and then connecting it to your Jovo webhook URL, and then testing in the Alexa skills kit simulator, or even on a device. That works as well, and that's how. Especially when the project progresses, that's always necessary to test on actual devices to see how the experience is gonna look and hear like for your users. And let's do that now. One big part of this example is project configuration that helps you build and manage projects in the Alexa and Actions on Google developer consoles. And you can find all of this here in the Jovo project.js. So the Jovo project.js file, we call it the project configuration. So this is basically data used by the CLI that that is then later deployed to the Alexa developer console, for example. And so we can take a quick look here. It's quite long, so it's gonna be just gonna remove that here for now. So this is gonna, there's quite a few lines, and it's pretty powerful with the staging and so on. And so feel free to take a closer look later in the example, but I'm gonna do my best to go through everything and explain everything. And so what we have here is we have plugins that can be added. So since version 4, this Jovo CLI also has a plugin architecture. And so here, for example, we have the Alexa CLI integration. What we do here in this configuration is we map the EN Jovo model to an EN US model, and you could also do stuff like this, like add more here. And so why is this done? This is because so we have this Jovo language model here. This is the Jovo specific model, and this needs to be translated by the Jovo CLI into an Alexa interaction model and a Google action model. And but we have en.json here, just one language model, and not one for EN-US, EN-CA, and so on. This works pretty well for Google Assistant, but Alexa doesn't support just EN as a locale, and this is why we have this mapping, so this EN gets translated into EN-US later. We're going to talk about the serverless configuration in a few minutes. And what we have here now is a staging. So the Jovo CLI also supports different stages. Here the default stage is dev. What we have here is we have the configuration for the platforms Alexa and Google Assistant for the dev stage. So the goal is in this setup to have 2 different Alexa skills and 2 different Google actions for the different stages. So we have one dev Alexa skill and one dev Google action with a specific configuration. And so we use the Jovo webhook URL. This is the link you get when running Jovo run that points to your local development server. We use that for dev, that you can develop locally still while using the while testing with a device, for example. And then we have a skill ID. We store everything in an environment file. And here what we also do is we use the Jovo file builder, which can override specific files in the in the platform-specific file packages to name it to append a dev, and in the prod stage a prod for the skill, so that you can spot in the Alexa developer console, for example, if it's a dev skill or a prod skill. And and so this file builder here is pretty powerful. You can add files, you can just modify files, and so on. So this is pretty helpful if you have anything that needs to be customized. So to get started, we're gonna take a look at this .env.example, and we're just gonna rename it to .env. And so you can see here we have this Alexa skill ID dev and Alexa skill ID prod. We're gonna keep this empty for now, because if we keep it empty here, if we keep this property as an empty string, then the CLI is gonna create a new Alexa skill when deploying. And okay. So let's do this. We first have to use the Jovo build command to build platform-specific files, and we can do this with Jovo build platform and then Alexa. Since the default is the dev stage, this is going to build the dev files. And one more thing to mention is the stage-specific configuration here gets merged into the stageless configuration, and so this locale mapping is going to stay the same thing. It's gonna be here for the dev stage and the prod stage. And once we're done, we can take a look at the build folders. We have a build folder here, and then a dev subfolder. So we have different folders for different stages. And here you can see, if you open the skill package and then interaction models, that is the ENUS file. We have an interaction model now being created based on the Jovo model. And here we have this the skill.json. And so this is what this file property did. It created this name. It was overriding this name. And here we have the Jovo webhook URL. So this is my personal webhook URL that is then forwarding requests to my computer. And so that is the result of the Jovo build command. So these files can now be deployed to the Alexa developer console to create a new Alexa skill using the Jovo deploy command. So the deploy command is taking the files from the build folder and then uploading them to the Alexa developer console. For this to work, if you haven't worked with Alexa before, you first need to install the Ask CLI. This is all explained here in the documentation. So what you need to do is install the Ask CLI and then run ask configure to configure an Ask profile. And so an Ask profile is so you could have different accounts in the Alexa developer console, and this is basically what an Ask profile does. It's connected to an account, and what we have here in the .env file is we just use the default, but potentially you could use different Ask profiles to deploy different skills in different stages to different accounts. For example, your personal and then a team account, or your account and a client account, and so on. Okay, so I already have that, and so I'm gonna use Jovo deploy platform Alexa for the deployment. And so since this is the first time this is gonna create a skill, it's gonna build the language model and so on, and this is gonna take a minute. So after the deployment is successful, it also spits out a skill ID. So we can copy this and add that to our environment file. So this way, because we have two different skills, we can just make sure that it's always kept in sync. Okay. So now that we have that, we can take a look at our developer console account. And what you can see here, we have that Jovo sample dev. We have that skill created with the invocation name my dev test app. This is also one thing that I can tell you a little more about. So for the dev stage, because it's pretty easy to run into problems when you use different skills with with the same invocation name. This is why for the different stages we have different invocation names, and this is used by using this models property here. So for the en model, it just overrides the invocation name, so it merges everything that's inside here into the language model before building it and turning it into an Alexa interaction model. So my dev test app is for the dev stage the invocation name, and the default invocation name, which will be used for the prod stage in this case, is my test app. And we can now go into the Alexa developer console. If we use Jovo run again, and start the server, we can test it. Okay, ask me. Yes, I do. Sorry, this is such a simple example. We really need to work on a more elaborate example which uses different components and conversational flows. But that's it. So you could test on the Alexa developer console. You can test on a device that's connected to that account, and it still goes to your local machine. And so you can see the requests being logged here. Here, yes intent, for example. And one more thing that is little known is if you keep the debugger window open, it also logs the requests here. So if we take a look at the launch request, we see this Alexa request here, for the yes intent as well, the response and so on. And so if you do testing for local development using using a device, for example, a voice-only device, then this can be helpful to just keep that open to keep score of the conversation. Yes, so that was the dev skill for Alexa, and I think we're pretty done here. And so this is the setup how you can build and develop locally using an Alexa skill. And we're going to do the next thing for Google Assistant. And so here you can find the configuration for Google Assistant. There's one necessary or one required property for Google Assistant. It's a project ID. So there's currently one limitation when building Google Actions. It's that the Google Actions API doesn't allow for project creation. And so this means that we need to go to the Actions on Google console and manually create a Google Action, copy the project ID, and add that to our project.js file, because otherwise we couldn't connect the project to our local project here. So this is why we need to go into the Actions on Google console and then create a new project. Just gonna call it Jovo sample dev custom blank. Okay. Okay, so this blank project was just created, and what we need now is the project ID, and we can find that in the project settings here. And so I'm just gonna copy that ID and go back to the environment file and go to Google Action Project ID Dev and add that here. And then we should be ready to go. So if I now use the Jovo build platform Google Assistant command, it's gonna build all the files needed for deployment using the gActions CLI. And so you can find everything here. So the webhook was added, the webhook URL. We have settings. So here the name Jovo sample dev was overridden by using this file builder. So same thing here, just use the path to that file, and then you can just do overrides, and it works with JSON, it works with YAML, and yeah, that's it. We can now deploy it to the actions on Google Console to add the language model and the webhook URL and so on. For this to work, you need to install the gActions CLI. There's a guide in the README of the example as well. And after that, you need to run gActions login. I'm already logged in with that account, and that is something important. So gActions doesn't have something like an Ask profile on Alexa, and so whenever you have different accounts and want to deploy to different accounts, you always need to log out with gActions logout and then log in again. And so I've already logged in, and so now I can do Jovo deploy platform Google Assistant. So nice, that already worked quite a bit faster than Alexa. So this just shows a few warnings because the sample project doesn't come with all the required information for certification. So before you go through certification, you need to add a privacy URL and stuff like this. But that's it. Let's run Jovo run again for testing and go back to the actions on Google Console. If I now open the develop tab, you can see the display name here, pronunciation, my dev test app. We have, I think I need to refresh one more time. Yeah, we have a yes intent and a no intent and all derived from the Jovo language model. And we can now go into the test tab and start testing. Okay, do you like pizza? Yes, we can use a quick reply here, or a suggestion tip as called by Google Assistant. Yes, I love pizza too. Same thing compared to Alexa. We have the request and response logged here. We can even see it in the debugger, or there might be a small bug here. Something is not displaying correctly. But yeah, that's it. This is how you can use the Jovo CLI to deploy to a Google Action project, how you can test a Google Action project on your local computer by using the Jovo webhook URL, which you can, by the way, find here in webhook. And that's it. So we now are at 50% of the setup. So we have a dev stage now, a dev stage that uses both an Alexa skill and a Google action and local development. And now to the fun part. If we now want to give it other people for testing, we can't keep our computer running all the time, so we need to deploy it somewhere. And very often developers deploy Alexa skills and Google actions to AWS, specifically AWS Lambda, which is a serverless environment for a serverless runtime. And we're gonna do just that, and we're gonna deploy our code to AWS using serverless. Serverless is a is a framework and CLI that helps with exactly that. It helps with permissions, it helps with deployment, creating everything Lambda functions, and so on. And we have an integration for that for the Jovo CLI. And we're gonna take a look at this now. And so what this does is you can add the serverless CLI integration to your project.js, and you can add all configurations that are needed here in a JSON structure here. So a service name, the runtime. Here we have all the permissions needed by our DynamoDB integration, and then also what is super interesting is that now Lambda allows for URL endpoints. And so in previous versions, you would need to have a Lambda for Alexa. So Alexa would point to that Lambda because it's still in the AWS ecosystem. But a Google Action, for example, would not be able to directly invoke the Lambda. And so this is why you would have to add an API gateway like in front of the Lambda that the Google Action could then call, and that would then invoke the Lambda. And so this took time, setup, costs, and so on. And pretty recently, Lambda or the team behind AWS Lambda announced the ability to use function URLs to invoke that functions. And with an updated version of the serverless CLI, you can now just use that parameter URL true to configure that URL or to enable that URL. And also we increase the timeout a bit because Alexa and Google Assistant also have they allow for like 6 to 8 seconds, I think. I think the default is 3. Yeah, so that's the default configuration, and then we have the configuration for the prod stage here. And so again, the prod, if we use the prod stage, the prod configuration here gets merged into the default configuration. We could have put, because we only use the serverless CLI for prod here, we could have put everything into the prod stage. But I'm assuming that for bigger projects, people would also maybe add a QA stage with its own Lambda, or sometimes it's called staging. And then you would probably not want to have redundant code here. And so this is why we have those two. Here, what the prod stage adds, it's just a stage prod to the Lambda, to the serverless configuration, an environment variable that is used by the DynamoDB table. We can take a look at the source code again at the app.prod. Here we have the table name that gets added using an environment variable. So we're just going to add that automatically. And also what we're going to do is we're using an Alexa skills kit trigger. And so this is the one that's needed for the Alexa skill to invoke the Lambda. And this trigger is tied to a single Alexa skill ID so that no other Alexa skill ID can invoke this code. And that's it. We can give it a try. Notice how this uses a prod skill, and so typically in the setup you would also create, how we did it before, create a new prod Alexa skill, and then copy that skill ID over into the end file and so on. We're just gonna just speed up things a bit for now. We're just gonna use the same skill ID here, similar with the Google Action, so that we don't have to go through this process again. And then later this can be removed again so that it's empty, and then you do a deployment and then a new skill gets created. But for now, so that this value here isn't undefined, we just copy it over. And then I can use the Jovo build serverless command. And so the serverless CLI integration registers its own command for the build topic here. And we're going to add the stage prod because the dev stage is the default stage, so that the prod configuration is used as well. And what this does is it creates a serverless.yaml file, and so it translates everything we have in here in this JSON structure into a YAML structure here. And so we can see it's nicely merged. The runtime and everything was from the stageless configuration, and the rest here is from the prod configuration. And so this file configuration, the serverless.yaml, is then used by the serverless CLI for the deployment. And this artifact here, the bundle.zip, this is something that the Jovo deploy command is gonna create first. It's first bundling everything up and then deploying it to AWS. And so you need to, I think it's just serverless. Yeah, so this is also in the README how you can, if you haven't installed the serverless CLI yet, how you can do that, and then you can use the Jovo deploy code command and then add serverless and then stage prod, and this is then gonna bundle the code and then deploy into serverless. Okay, so while this is deploying, we can take another look at the configuration for Alexa and for Google Assistant. And so for Alexa, we have a potentially different skill ID, a potentially different ask profile, and also an endpoint. And so it will be a different endpoint, not the Jovo webhook URL. It will be a Lambda ARN, the Amazon resource number, and so this is used to invoke AWS resources internally. This is not what the Google action can use. The Google action will use the Lambda URL. And this is also the reason why the endpoint configuration in this stage is right inside these platform plugins. In the dev stage, we just had an endpoint outside here, and this was used by Alexa and Google Assistant. And so because there is a difference here in the prod stage, we need to define them right inside those configurations. And then the names will be used called prod and so on. And that's it. Okay, so after the deployment is completed, we can go to our AWS, and we can find it here, the Jovo sample prod handler. And so this was just created 38 seconds ago. You can see the Alexa skills kit, the skill ID here, the Alexa skills kit trigger. For permissions, you can see that we have the permissions for DynamoDB added as well, and that's it. So that is created, and also something that we can test out is we can test out if it works if we invoke it from a platform, and we can do so because we have added the same project ID here to prod. We can just build the prod stage for Google Assistant. And then do Jovo deploy platform. I missed one thing. So what we need to do now, of course, is copy the function URL and the ARN. So this is the function URL, and here we have the ARN. you can also use the serverless info command, which is gonna retrieve some information. So you have the endpoint here, for example. And then let's build it again. So yeah, and if I now go to the build folder and the prod folder here and go to webhooks, you can see that we now have this Lambda URL. And now if I deploy, and go to the Google Action Console, now you can see that it changed the name here. So it is recommended to use different actions, of course. And now go to the webhook, you can see that everything was updated. And if I now test it, the first request is gonna fail because on the first request it's gonna create a DynamoDB table, and this is also what this permission is for here. The create table and the describe table is also used to check when it's created, and so on the first request it's gonna create that table, and then the next one it's gonna work. Okay, so now it works. And so we now have a broad Google action that invokes a Lambda that is connected to a DynamoDB. You can always keep making updates to that Lambda from the Jovo CLI using the serverless CLI. And yeah, that's it. This is how you can build an Alexa skill and the Google action that is used for both local development and can be deployed to AWS Lambda. Feel free to take a look at all the configurations and feel free to submit any issues if you have any questions, or submit pull requests if you have anything that could be added to make that process easier. Yes, thanks a lot, and yeah, let me know if you have any questions, and see you soon. Bye.